Hello all, and welcome to this webinar. My name is Fabiana Gonçalves, and I will be I am a product marketing manager at Azion. Well, in this next hour, we will show you how to simplify processes and reduce latency with edge solutions. We invite experts from Azion and Fauna to present these topics and answer any questions you may have. We will have a Q&A time at the end of this webinar. But feel free to submit your questions at any time during this presentation. If we won't respond to everyone, we will contact you by email. We will have Pablo Dio, serverless software engineer at Azion, and Ziku, head of solutions architecture at Fauna, is speaking with us in this webinar. Pablo has 5 years of experience with edge computing, worked on numerous types of stack from front-end, back-end, embedded, and mobile. And Z has 5 years at Okta as a solutions architect and 20 years of developer experience with insurance, health tech, gov, and identity. But before starting and give the floor to the specialist, I would like to briefly introduce Azion and Fauna. Fauna is a distributed document relational database delivered as a global API. It combines support for semi-structured data with powerful relation features such as foreign keys, views, and joins. The fact that it is distributed by default makes it a really strong data store for applications delivered on the edge with Azion. Azion simplifies how you build and run modern applications anywhere, on Azion's operated network edge, remote devices, on-prem, or multi-cloud. Azion's full stack platform is highly distributed with automatic deployment, monitoring applications, and managing the whole CI/CD pipeline. The Azion platform is based on open standards with built-in security, complying with local laws and regulations. Well, guys, I wish you all a great webinar, and I will hand over to Z.
Thank you, Fabiana. Great intro. And thanks everyone for joining us. A good morning or good afternoon or good evening, know where you're coming from. And I'll remind you, if you have any questions while we're presenting, you can use the Q&A. It's the control in the Zoom control. There's a Q&A. Just click on it and submit your questions there. So that we can have it and prepare when we respond to you at the end during the Q&A session. So with that, let me give you a quick introduction to set a context of what we're talking about here. We're talking about edge computing and building applications using edge computing architecture. Now, according to Gartner, which released a report in 2018. So back then, they released a report and they predicted that by 2025, 75% of the enterprise data would be created outside centralized servers. So that's what they said in that research. In a separate research, not Gartner's, a separate research, it says that same year, 2025, 30% of the computing workload in the world will be done outside central servers. It'll be done at the edge. So that's 3 years from now, actually, right? In fact, very close. We're almost at the end of 2022. So how accurate is these predictions? So before we try and answer that, in fact, we'll spend most of this talk trying to answer that. Let's talk about what they mean by edge computing. So edge computing is actually very, very broad. It covers many, many sectors. So it could be very high end in edge computing, like you'll find in autonomous driving. You'll find it in voice assistants, like, you know, the gadgets in your house, Siri, Alexa. In your car, there's actually also voice assistants in your car now. You can see that a lot in the high-end manufacturers. There's other sectors in edge computing, so you can think of traditional IoT, which range from customer type of use cases, think of your smartwatch, to like industrial and manufacturing. So think of sensors that are placed around your factory that are simply just measuring temperature or humidity or whatnot and sending data back to a server, doing some small calculations at those sensors. You can see also very mundane use cases, such as, well, your city basically putting a Wi-Fi on your water meter. So you can, these are, right, very, very broad use cases. But since this is Azion, we're talking about Azion and we're talking about Fauna, and hopefully you guys are also developers and you're building applications for end users and businesses. Let's narrow down the scope of what we want to talk about in terms of edge computing. We're talking about using edge functions in your applications and going serverless. So let's talk about this. Applications are very far reaching. There are a lot of them, and most of them are built in very traditional ways. When we talk about this massive uh, population of computing and moving that to the edge, you can start to understand these predictions could be true. I mean, after all, they're only talking about 30%. So are we going to get there? So here's the argument. The first argument is, oh, maybe we're not going to get there. Why? Well, here's the reason. Computers are still getting very strong. So you can have really, really large instances in your cloud provider, right? Or let's just talk about the use cases. Maybe that data doesn't have to be processed immediately. So you can just ship that data and you don't care about the latency. So it just spends a long time getting to some centralized database. Let's talk about computing. Well, computing is very easy to horizontally scale. Just add more VMs and just, right, more and more VMs, scale them. So that's the case against, well, we don't really need edge computing. What use is it? Well, let's talk about the cases for it. Your latency is, after all, limited by the speed of light. So if you're building applications and trying to get your users the best experience, you want your compute to be close to where the user is making that request. And then there's limitations in the amount of data that you want to push to some central location. So that's bandwidth network congestion. So if you can process that data at the edge, you can relieve this network congestion, right? At the end of the day, you can get really responsive applications and you can serve your customers better. So in simplest terms, edge computing moves some or all of the portion of compute and storage resources away from the data center, closer to the end user. And we're doing this today, right? We can do this today using edge computing functions. Now, what's most importantly differentiating about edge computing platforms compared to a traditional cloud is it is also serverless. So what I mean is you don't have to maintain any infrastructure, right? So take a look at Azion Edge here. First of all, you can compare it to the left side, way more distributed than a traditional cloud. So you can get closer to your end users, okay? And it is no ops. Traditional cloud, very operational intensive. You might be familiar with that. Azion is based on open standards, and it is built with securities centric focus and also adhering to local compliance depending on where that edge is located. In this map here, we're just showing Americas, but Azion is really distributed globally. So, but we're just focusing on the Americas right now in this diagram. So what are people doing today? What are they building using edge functions? There are, I think, maybe 7 broad categories. I'll talk about them like really quickly. One of the most common use cases is to just easily add security to your HTTP request. So you can easily add the security headers to your request and responses. You can easily add authentication and authorization to your API, right? So that bearer token that you add into your request, your API request, the bearer token can be either introspected at the edge, or the signature of that token can be validated using some library at the edge. You don't have to send that all the way to your origin, to your server, and basically add load on your server. All this can be done there, which also improves the latency of that API request. So here's another category of what folks normally do with the edge functions. Dynamically route the request to different origins based on your viewer characteristic, right? So one of the good examples, the edge can use a geo API to figure out where that request is coming from, and it can route to a server that's closest to that geolocation, and that results in improved latency. You can deliver a pre-rendered HTML page that's stored in cache, in static storage, so that, you know, if the request is coming from a search engine, it can actually crawl that page, right? And then you can serve different versions of your website without changing the URL. And this is very useful for A/B testing. But what else can you do? You can transform images on the fly, again, depending on user characteristics. So it can see your user agent in the header and see that you are using a browser, a tablet, or, you know, a smartphone, and then it can basically use that information to give you the best optimized image or video for that device that you're using. And then lastly, it can simply just add as a router for data. So it can log all that information that it's capturing at the edge to maybe some data lake for further analysis. Now, one of the most powerful things that are unlocked by using edge computing is you can start to build apps serverlessly. And this is where Fauna comes into the picture. The edge functions, we can get to 30%, right? If more and more applications can be built this way in a new architecture, where you don't need servers and you don't need databases in a central location. So are there more teams adopting this edge serverless architecture? We call it edge serverless. There are traditionally two blockers to doing this. The first blocker is, well, it is actually difficult to achieve consistent latency from edge function to a database. What I mean is, even though the edge is distributed, right, and it's close to your end user, if you have your database only in one central region, that database is only close to the edge nodes that are close to the database. So that means some users will have good latency and some users will have bad latency. Okay, so what you do normally is you want to take that database and you want to replicate it to other regions as well. Now, when you do this replication, there's a problem, right? You add additional overhead in operation, and replicating databases and using the techniques of traditional databases to keep the data in sync and maintaining consistency in that data is actually pretty hard. You may have heard of the term eventual consistency, and that's what folks normally have to deal with when they think about replicating their databases over different regions. Problem number two, you get all this additional overhead right? Because it's no longer a simple single database. You have to replicate it. You make sure all of them have to, synchronize, etc. Use all these different tricks. That's additional overhead. But way at the beginning, we say, well, we want to use edge platforms because it's zero operations, it's serverless. So now you brought back all these operations problem, all these operations overhead, then you're not truly serverless anymore. So actually that goes against your original plan. What you want is a database that is also serverless, number one, with zero operations, delivered to you as an API. There's several of those. And then you want to also solve the consistency issue. So with Fauna, we automatically replicate your data. It's automatically distributed. There are copies of the database spread out far apart, which means that if you are making a request and the request comes to the edge, it will be routed to, right, a replica database that's closest to it. That means ultimately your end users, depending on where they are, will see consistent response to the application, no matter where they are. Now, this is made possible because we built from the ground up and we're not using an existing database technology. We use something called Kelvin algorithm, which basically predetermines the order of transactions coming in, and then the replicas basically all get all the same orders. So essentially replicas don't have to coordinate with each other. These transactions that the database receives are predetermined ahead of time. And when we do something like this, a commit would only require something like 50 milliseconds. So we have a database. If you pick the US region group, that means we have coverage for the entire US, right, east to west. And when you make a transaction to Fauna database, it commits that right in about 50 milliseconds internally. So that's internal. And then you add to that the network latency. And like I said before, that network latency is minimized because there are replicas, right, in the east, in the west, and in the central United States. And lastly, we don't deal with eventual consistency. We have ACID compliant transactions. So this is what it looks like. Active writes, automatically replicated, right? And that's what we have there in US. It looks like this in EU. So when you create database, you can pick US, you can pick EU. We have a special type of database region group that's called Classic, which looks like this. So now you have replicas all the way across from US all the way to EU. You may not realize it, I'll call it out, even if you're a user in Asia, like, Japan, Korea, that actually gets served by the Western United States with over high speed fiber that goes through the Pacific Ocean. So it's still pretty fast. And then we're going to create more of these region groups as you go. And for some of our customers, they actually request for their own private fauna. We call it dedicated fauna, and they can put them any way they want in any footprint that they want. Now, fauna is it is a document database. You might be thinking of it's kind of like MongoDB, kind of like DynamoDB, so document database. But we're different in that we can support joins. So we're also like a relational database. Also like a relational database, we are ACID compliant. And also like a relational database, we support the concept of stored procedures. So you can write pretty complex business logic using the query language. This could be very important to solve latency issues as well, because what it means is that you only make a single request to the database, and then this stored procedure can update a lot of tables or read a lot of tables at the same time and just do a single response back to the client. So ultimately, this gives you two things: ACID transactions and very good latency profile. So how here's some common use cases, right? Build your API just using edge functions and Fauna, okay? This is a very new approach that a lot of folks are doing. You can't really install a database on edge location, right? You need a database that's serverless. So a lot of folks most commonly use the combined Azion and Fauna to build an API. Well, another way to think about it is I have a traditional application, right? But I want to enhance that application. So I can do that easily without touching my core code, my monolith code, because I don't want to change it anymore. I can just basically stitch some other data source into that pretty easily. It's an API after all, right? I can enrich the data. I can do things like detect where my request is coming from using a geo IP API and serve localized content depending on where that request is coming from, et cetera, et cetera. And then the last thing, this one's a very powerful use case. And then Pablo is actually going to go in detail about this. So think about all your edge locations spread out, and they actually need a single state, basically need a single state. And because we're ACID, we provide this state to all these multiple edge locations, and it unlocks a very powerful use case about enabling global rate limits with penalty. So with that, I'm going to pass this over to Pablo. We'll talk about this really interesting use case that they leverage Fauna for one of their customers in Brazil.
Thanks, E. So let me share my screen. So thanks everyone for connecting to this webinar. I'm going to present you a use case where we joined forces with Fauna to create a more robust rate limit solution for one particular customer we have here at Azion. But before diving into this new solution, I'm going to take a little look at how our default rate limit solution works. So to use rate limit at Azion is really simple. All you have to do is go to your red firewall and use the behavior set rate limit. In this example here, I'm setting a limit of 2 requests per minute based on IP address. But there is an important aspect of how our rate limit works. That is, this rate limit is local in each of our edge locations, because our edge locations, they do not share data, request data with each other. So in this example of 2 requests per minute, let's say we make 3 requests in a row for a same edge location. The two first requests would be allowed to pass by, while in the third request, we would be blocked by the rate limit behavior and would keep being blocked if we're still trying to make requests until this rate limit is expired. But let's say after the third request, in the fourth request, we end up being routed to a different location. In this second location, we would not be blocked because for this second location, that was the first time this location saw this IP address, because there is no data sharing between our locations. So with this context about how our rate limit is local and not shared, we go to the use case itself. So this very important customer, they didn't quite understand how our rate limit worked. They thought our rate limit was global, that it was shared between all the locations. So they thought whatever 3 requests I made, doesn't matter that location that received this request, in the third request, I should be blocked, and they should ended up being blocked in all other locations. They also wasn't satisfied with the how the penalty works in terms of time. They thought they could customize the amount of time the users will be penalized for instead of just the reminder seconds of the penalty window, of the rate limit window. So we had to find another solution for this customer. And soon we realized that we could not fix this problem within the Azion platform because of the data sharing that already at this location do not do. So we had to find a solution outside of the platform. That's when we remembered of partner that we had just integrated onto our marketplace. That was Fauna. Our first idea was to replace our rate limit behavior with a whole new logic in Fauna. So instead of doing the rate limit locally, we would send a query to Fauna and get this result if we should allow the user to pass or if we should block the user. However, querying to Fauna in every single request was a little bit expensive in terms of request latency. And as one of the main purposes of eddy computing is to make our application faster, this didn't quite work as we expected. So we had to find another solution. And fortunately to us, this second idea was the definitive one. So we thought, what if we kept the rate limit local, but we just used Fauna to retain the bad usage data and use this in a more efficient way. This way, while we wouldn't have a global rate limit itself, we would have a global penalization through our allocations. And we also would allow our customer to define the amount of time the user should be penalized for violating the rate limit. So how did you actually build this solution with global penalization and custom penalty time? The first step was to replace our rate limit behavior with an add function. And this add function would not just make the local rate limit, but also whenever it identified a violation, it would send the IP address to a Fauna collection. And now that we had all this information in Fauna with all the IP addresses that should be penalized, we had to find a way to use this information to block bad user requests to the ad application. And we did this by creating a script that goes to Fauna, runs an UDF, and retrieves the data with the IP addresses that should be penalized. And we use this data to update a network list. Network lists are structures we have here at Azion that allow you to control the access to your application based on network aspects, such as geolocation, AS number, and IP addresses. So now we have this network list up to date with all the bad IP users. So how we actually use this to prevent these IP addresses to reach our application, we just go to our add firewall rules engine and create a rule where we use this network list as a criterion for whatever the request is made for an IP that is in this list, we deny the request. With this, we built what we call today of rate limit with penalty cycle, where we have the users making requests to the ad application and executing the add function that counts the rate limit locally, and whenever a violation is identified, send these IP addresses to Fauna. And we have the script that goes to Fauna, gets this data, and uses this data to update this network list. And the network list finally is used to prevent those bad users to reaching the ad application. With the cycle, we managed to solve the problems our client had with our rate limit solution, because we solved the global penalization issue, and we allowed them to control the amount of time the users would be penalized for. And we did this without affecting the latency for the final users of the ad application. Our customer is running this solution for almost a year now, and they are really satisfied with the results. They were able to solve lots of attacks with this solution, and they are pretty satisfied with it. So I guess that's all I had to say today. We can move to the questions and answer section.
Thanks, Z and Pablo, for this presentation. We have a couple of questions here sent. So I have two questions for Fauna. So Z, I'm gonna ask you to help us to answer them. So the first one is how some developer can run Fauna locally for developer purposes.
Oh yes, you can run Fauna locally. There is a Docker image. It's called Fauna Dev, which you can find a link to in our developer docs, and it has the full power of Fauna. So remember, this is it's delivered as an API, right? So all you have to do is bring up this Fauna Dev. There's no UI to it, but Fauna, you can interact with Fauna like a traditional database using a CLI also. So when you bring up the Docker image, you can essentially use it using the CLI. And then when you have an application, you just point it to localhost and some port where the Docker image is running.
Okay, good. The Fauna staff just posted on the chat the link, so you can go and check it out. What Z just said, right? The next question is how we configure Fauna for distributed replication.
So like I mentioned earlier in the slide, I said that, hey, we automatically like replicate and distribute the data. That's actually nothing that you have to do. It's completely transparent. So you pick a region group, US, EU, Classic, and you create a database, and that's all, because that database you create is automatically replicated already and automatically distributed. There's nothing you have to do. You saw the footprint in the earlier slide. US, if you pick your database in the US, it's replicated across US. If you pick EU, it's replicated across EU. And then you pick Classic, it goes from Western United States to like Eastern Europe. So it's all automatic with no additional replication, which means no overhead, no operations, no maintenance.
So we don't have to deal with eventual consistency, right?
That's the trick, right? It's different from the databases that are built with traditional technology. Remember, databases have been around for decades, and in the old days, you don't really have a use case where you have a distributed application with users that are distributed. So, right, it's just not made for that. But they have over the years basically leveraged certain things about databases. So you can create replica databases. I'm talking about traditional database. You can create replica databases, and obviously you can put that replica anywhere you want, creating that same distributed footprint. except that the replication mechanism is sort of like a streaming from a master database to the others. What it means is only one database you can write to, and you cannot write to the others. So while you have no problems in the reading, in writing, again, users are far away from that master database are going to have really slow latency. And then even in reading, it's really hard because you have to, if you want those consistent ACID transactions, you have to wait for the replication to finish, sort of just waiting for this round robin to the other replicas to happen. So that's normally what you see there. With Calvin, you don't do that. When you, right, when you do something, it goes to a global transaction log. It pre-orders, it batches up all the requests it receives in something like 10 milliseconds, provides an order to all those transactions, and then each replica is just streaming the log to themselves and then applying the changes that it sees in the log. That's really how it happens. Again, you pick US, a commit is 50 milliseconds, which is actually pretty acceptable for something in that footprint.
Nice. Now I have here, where do I go to sign up for a demo and learn more? I can, Z, do you wanna ask
Yeah.
or like answer for
So,
Fauna, where guys can go and sign up for a demo? I can answer for Azion.
where can we, you definitely can get a demo. So I actually do a live demo on every Fridays, which you can sign up for. If someone can paste a link there to the demo sign up, I actually do that. You can also contact us directly. We'd love to talk to you, and then we can have a face-to-face, right? A Zoom meeting, and I can provide a more customized demo for you there. Oh yeah, and then
And,
there's a recorded version also of the weekly demo. We pasted that link there for you.
and guys, if you want a demo for our platform, you can join Azion and ask for to contact us, and we can get in contact with you guys and set up this demo for you. So it's very easy also. Another question. Do you have a free account or tier? I can answer with Azion. Azion, you can have, you can sign in for free, and you get $300 credit, valid to use the platform for 12 months. So you can, you already use the platform for free using, and when you add our products, you can use our credit to use it. So yeah, you can do that. Just sign in and at azion.com.
Yep. And same, Fauna has a free for life developer plan with limits, but it's a pretty big limits there. It's you can store data up to 5 gigabytes, and then it provides you monthly 100K read operations, 50K write operations, and 500K compute operations. What are these operations? Read, write, compute. If you're using a system, another server system such as Dynamo, which we modeled it, the billing on, you'll be familiar with it, right? It's a way to basically keep track of the type of operations you're doing against the database, right? Reading, writing, right? Reading, writing, compute. Again, I said we can do like complex storage procedures type of things. So you can call a lot of functions so the compute ops. So it's all based on consumption, and then we put some limits on those consumption. And if you stay under those limits, it's free for you.
Yeah, the platform user based. Azion is user based, so you can get your $300 credit to use it. Well, guys, we don't have any more questions. We still have a few minutes. I'm gonna give you more 2 minutes. If we don't have any questions, we can end it. Let's see if anybody will have more questions. Let me check it out here. Um, no. Okay, so nobody has more question. Have more questions? Okay, there's another one. Okay. What are Fauna's different deployment methods?
Yeah, when you sign up for an account, you can create databases, unlimited databases. It's all usage based, right? So, and I mentioned already, you can pick US, EU, or Classic to create those databases. Those regions are what we call the cloud fauna. It is a multi-tenant. It's shared with thousands of other accounts. Now, if you want your own fauna, we can do that too. So you're not shared your own fauna, and you can say you want to put it where you want, just in Brazil, where in Brazil, Western Brazil, the whole Brazil. You can do, you can just get your own fauna and we can set it up for you. So those are the two different deployment methods.
Okay, guys, I want to thank you all to attend, and thank you for presenting this webinar. This webinar is going to be is already recorded, and we are going to share. Also, is going to be a link on our social and platforms and our website, so you can check it out. And thank you very much. If you guys have any more questions, feel free to reach out to our contacts on Azion and Fauna, that we can help you on that. Thank you very much. I'm going to end the session. Bye, guys.